Hello and welcome to my YouTube channel. In the previous tutorial, we have seen what exactly Zookeeper is, how exactly Zookeeper addresses the problems faced by distributed systems. In this tutorial, we are going to dig a little bit deeper into Zookeeper service. In this tutorial, we are going to see what Zookeeper data model is, and under this section, we are going to see what exactly a typical file system means, what are Znodes and what are the different types of Znodes, what exactly Zookeeper file system means, and what does a Znode stat means. So let's get started. In a typical file system, consider you have a Unix operating system. What you have is you have a root folder, which is basically a root directory. In that directory, you can have multiple subfolders. Let's say in this case D1, D2 or D3. And every single folder or directory, you can store some documents or files, let's say. So this is what a typical file system looks like, in which you can have directories, and inside directories you can have files. Now, before going to Zookeeper data model or Zookeeper file system, let's talk a little bit about Znodes. So what exactly Znodes are? So in a typical Zookeeper tree, which you're going to look into a little later, so every single node is basically known as a Z node. Now, every node or a Z node maintains a stat structure that includes version number for data changes, ACL changes with timestamp. We're going to look into all these things in detail in a while. Z node also has timestamp and version number, which actually helps the Zookeeper to handle updates. For an example, whenever there is a change in the node, a Z node, version number gets updated. We are going to see this practically in the forthcoming tutorials. So just to brief this, let's say there is some error or some issue which is happening, because of which there is a restart which happen, and during all these situations, so basically timestamp and version number actually helps to know whether the data is updated or not. Any change in Z node can be notified to the client using watches. There is a separate tutorial for this. I'm going to talk about it in a later tutorial. Also about the ACL. So in every single Z node, we have access control list, which is ACL, which actually restricts who exactly can do what, which actually defines the access to a particular node. Now, Z nodes are basically of three different types. The first type is ephemeral nodes, the second is sequence nodes, and the third is persistent nodes. An ephemeral node is basically a type of Z node which is associated with a session, which is basically a session level node. These nodes does not have any children and are deleted as soon as the session ends. Now, what are sequence nodes? Sequence nodes have a unique sequence number associated with every node. For an example, let's say the path to that particular node, and it will be having a 10-digit number with some sequence number. Now, what exactly persistent nodes are? So they are basically a type of Z node which remains in the Zookeeper until deleted explicitly. Now, all these nodes store small amount of data, like configuration data, that can be shared across multiple nodes based on the access which is being provided by the ACL and all. Now let's see how exactly a Zookeeper tree looks like, and how exactly a Zookeeper file system maintains the node and everything. So this is a typical Zookeeper tree, and these are the Z nodes. So for an example, let's say you have a root Z node, which is basically a // and these are the children of that particular Z node. So we have a Z node 1, Z node 1, under that we have A as another node, and so on. Now, one of the difference that you're going to see here is, in a typical file system, a directory does not have any stat or any details which is actually being attached to that. We can store information in the form of files inside a directory. But in a Zookeeper file system, basically every single node will have certain amount of data which is actually being attached to that particular node. So here you can see each and every node has some or the other information which is actually attached to it. Now, if I zoom one particular snapshot here, so it contains these all informations such as CZX ID, C time, MZX ID, M time, PZX ID, and so on. We're going to see all these things in details. Now, let's dig a little bit deeper into what exactly Znode stat is. So, the zoomed version, which you saw in the earlier slide, was basically this. And Znode stat means the statistics or the stat or details of that particular Z node, having all these informations. So let's see what exactly all these key names means in terms of Zookeeper. So ZX ID is basically a transaction ID of this node. So let me give you some information on what exactly transaction means here. So Zookeeper basically maintains a client server model. So here Zookeeper is a server and we have multiple clients who are actually trying to access or who are actually coordinating with Zookeeper for multiple services that Zookeeper provides. Now, what happens is whenever a client comes in and who's trying to coordinate with Zookeeper nodes or Zookeeper server, every single communication happening between the client and server, which is Zookeeper server, is actually considered to be a transaction. We are going to see this in detail in the forthcoming tutorial. For now, that is what ZX ID represents. It is basically the communication between client and Zookeeper server, and it has a particular ID which actually represents and what exactly is happening in the status of that. Now, what exactly CZX ID mean? It is basically the ZX ID of the change that caused this node to be created. Now, what MZX ID means is the ZX ID of the change that last modified this node. This is basically a last modified transaction ID. Now, C time is basically the time in milliseconds from epoch when this node was created. M time is basically the milliseconds from epoch when this node was last modified. Here M means modification. Version number is basically the change to the data of this node. If at all anything happened and restart happened and all, so this version is going to actually track all those things. Now C version is basically the number of changes in the children of this node. So every single node has multiple children. It is not necessary that they are leaf nodes as well, but let's say they are internal nodes, so there might be some changes to the children. So those kind of things can be given by the C version. Now, what exactly A version means? The A version is the number of changes to the ACL of this node. Now, every single node here basically has some kind of ACL, which is access control list being defined, which actually allows to the user to access like the privileges that you define. Now, what exactly ephemeral owner means is the session ID of the owner of this node if the Z node is an ephemeral node. If it is not an ephemeral node, it will be 0. Now, what exactly ephemeral node means? The Z nodes exist as long as the session that created the Z node is active. When the session ends, the Z node is deleted. Because of this behavior, ephemeral nodes, Z nodes, are not allowed to have any children as it is not being persisted and it goes off as soon as there is no session. Now, what data length is? So it is basically the length of data field that you are attaching to a Z node. So you can actually add some information in the form of data to every single node here, and this data length is going to represent the amount of data which you have attached to a particular node. Let's say this Znode stat is for Znode 1 here, and in Znode 1 I haven't put any data, so the data length is 0 here. And called Zookeeper, we are going to see a Zookeeper my ID, what exactly it means, which is actually very, very important. We are going to see how Zookeeper stores the data and how Zookeeper maintains logs. What Zookeeper or ZKCLI means, which is basically the Zookeeper command line, and how do we read the logs, and what a snapshot means, how do we read it. If you like this video, please do subscribe to my channel, and thank you very much for watching. See you in the next tutorial.